This is number 7, and the question says you should find the relative minimum and relative maxima of this function. All right, so the first step to take is to differentiate this and look for the value of x. All right, so when we'll differentiate this dy dx, I believe everyone should be at this stage should be conversant with using the general method to differentiate any function. So it's simple. You simply take the power and multiply by the coefficient here. So the power here is 3 times 2. We have 6. We have x. Then subtract 1 from the power here. 3 minus 1 is 2. That's just the simple thing. Simple way to differentiate using general formula method. Minus take 2 here. Remember, there's the power multiplied by the coefficient, and we have 6. 2 times 3, 6 x. And we have 2 minus 1 is 1. So this is just 1. Minus, we have the power here to be 1 multiplied by 12. You still have 12, and then you take the power. 1 minus 1 is 0, and then you know x raised by 0 is 1, because any term raised by 0 is 1. So that is that. So plus 8. Whenever you differentiate the constant, you know you have 0, so it has gone. Now the next thing you want to do is we have to look for the critical values of x. All right, so to do this, we have to set dy dx to be equal to 0. And that means this entire thing here will be equal to 0. So we have 6x squared minus 6x minus 12 will be equal to 0. So we can go ahead to factorize this, but for that we can simply divide all through by 6, right, to make it simpler for us. So if I divide all through by 6, I should have x squared left here minus, I should have x here, right, and I should have 6 into 12 is 2 equal to 0. And then sorry, we can now go ahead to factorize this. All right, I believe at this stage as well everybody should be conversant with factorizing quadratic expressions. So if I go ahead to factorize this, I should have x minus 2 into x plus 1, which is equal to 0. And from this equation here, we know that x is equal to 2 or x is equal to negative 1, because if I bring negative 2 here, I should have 2. If I bring 1 here, I should have negative 1. So these are my critical values. So I will use these critical values to run the second derivative test. All right, so let us differentiate this for the second time. That's what we call second derivative. So that means it looks like this: the square y over the x squared. Right, so we have to differentiate this function here twice. So when we differentiated once, we had 6x squared minus 6s minus 12. So we're going to differentiate this again for the second time. So remember how we do it. We take the power here, bring it here, it becomes 12. 2 times 6, 12. And then 2 minus 1 is 1, that's that. Minus, the power here is 1. 1 times 6 is 6. And 1 minus 1 is 0, which means x raised by 0 is 1. And then we have a negative 12. Of course, you know, if you differentiate the constant, it turns to 0. So this is what we have. Then we know that at maximum points, the square y over the x squared is usually less than 0. It's always less than 0. Okay, and at minimum points, the square y over the x squared is usually greater than 0. So we're going to test our critical values of x to know which of them will give us the maximum point. Now, relative minimum and maximum simply means the highs. Okay, when we talk about maximum, relative maximum, talk about the local maximum points, you know, in a region of the curve. And then when we talk about relative minimum points, we talk about the local minimum point at a particular region of the curve. Okay, so let us test this now. So we're going to use our critical values of 2 and negative 1 and put it inside of this second derivative. If it gives us greater than 0, we know is what? A minimum point. If it gives us less than 0, it's going to be what? A maximum point. All right, so we can say that when x is equal to 2 for the first case, that means the square y over the x squared will be equal to what? 12 into what? 2. Remember, whenever I see x, you put 2 minus 6. Also, 12 times 2 is 24, which is 24 minus 6 is what? 18, and we know that 18 is greater than 0. So we have a minimum point here at x equal to 2. Okay, so we'll also check for the next one. We'll say when x is equal to -1. All right. Okay, let me wipe this off. The we have gotten the minimum point, the x value at the minimum point. So we can say that when x is equal to -1, so let's test for the second critical value. When x is equal to -1, and then put it into our 12x minus 6, we should have that the square y over the x squared should give us equal to 12 into -1 minus 6, right? I know that 12 into -1 is -12. -12 minus 6 is -18, which is less than 0. Okay, so now we've gotten a maximum value of x, right? Now we can say therefore the relative maximum, let me just put it as max, all right, will be when x is equal to what? -1. Remember, maximum is always less than 0, and we got it when x is equal to -1. So the relative maximum will now be the y value when x is equal to -1. Now remember, the initial function was what? Y is equal to 2x cubed minus 3x squared minus 12x plus 8, if I can recall very well. So we're going to put x as -1 inside of this to get our relative maximum. Okay, so it's going to be equal to 2 into -1 cubed minus 3 into -1 squared minus 12 into -1 plus 8. All right, and then -1 cubed should be -1, right? And -1 times 2 is -2. This -1 all squared is, which is 1, because -1 times -1 is 1, and -3 times 1 is -3. -12 times -1 is plus 12. We have plus 8, so add up everything here. 12 plus 8 is 20. 20 minus 3 is 17. 17 minus 2 is 15. Okay, so this is equal to 15. This becomes our relative maximum. So to get relative minimum at, where will it be? At x equal to what? 2 this time around, because it was when x was 2 that it gave us greater than 0, which is the minimum point. Okay. All right, so we can now say that y will be equal to what? 2 into 2, just replace x as 2 here, minus 3 into 2 squared minus 12 into 2 plus 8. We know that 2 cubed should give us 8. 8 times 2 is 16. Minus 2 squared is 4. -3 times 4 is 12. -12. -12 times 2 is -24. And we have plus 8. Okay, so we know that 16 plus 8 is 24. 24 minus 24 is 0. 0 minus 12 is -12. So this becomes your relative minimum. And so we've gotten a relative max and relative mean. Now this function doesn't have an absolute maximum and minimum, and the reason is because the range of values for x goes from -infinity to +infinity. But we'll not dwell much on that, okay, the explanation of that. So this is just the answer to the question. You have your relative max and your relative mean.